Today we're looking at two important concepts in coordinate geometry, which are the y-intercept and the gradient. Let's have a look at the gradient first. So the gradient has a symbol, and that symbol is m. So whenever we're talking about the gradient, we use the symbol m, and the formula for the gradient m is rise over run. So let's have a look at what these two terms are, rise and run. Now I'm just going to plot or draw two coordinates on my Cartesian plane along my line here. So I'm going to put one here at 4, 4 and another at 2, 2. Okay, so I'll just also write my coordinates here, 4, 4 and 2, 2. And what I'm going to do, I'm going to draw a dotted line at a right angle to my line. So what is the rise? Well, the rise is the difference in the y values of these two coordinates. So it's a difference in the vertical height of our two coordinates. So I can label this one here as rise, and the one along here is run. So run is our difference in the x values of our coordinates. So I'll also write that in here. So rise is difference in the y values of our coordinates, and the run, of course, is the difference in the x values. Okay, so you may want to remember the formula for gradient as a difference in y values and a difference in x values. So with looking at our two coordinates now, we've got 4 over 4 and 4, so 4 x value, 4 y value, and 2, 2. So we can quite simply work out the difference in y values. So look at these, the y values, 4 and 2. So 4 take 2, of course, over 4 take 2. Okay, and that works out to, of course, 2 over 2. And we always simplify the gradient if we can, and we can simplify that to 1. Okay, so the gradient is just a simple concept to follow. It's just knowing the rise and the run. What does rise and run mean? And it's just the difference in our y values, or the height difference between the two coordinates, and the run is just the difference in the x values or the horizontal distance between the coordinates. Now there are several types of gradients. What we've just seen is a positive gradient. This one here, which we saw before, you know it's a positive gradient because when we're going along the x-axis from left to right, how we would normally read, the y values increase, okay? So left to right, the y values increase. Now, when you're going left to right and the y values decrease, we say that is a negative gradient. So we see this line here, sloping downwards. So that is a negative gradient. So I'll just label these. This one is our negative gradient, and this one's the positive. Okay. And as long as you're reading it left to right, you just see, are the y values increasing? Then it's positive. If the y values are decreasing, it's going to be negative. Okay, and now we've got two special gradients. We've got the horizontal line. The x values increase, but there's no difference in the y values. The y values never increase. And then we've got this one here as well. So the y values increase, but the x values never increase. Now this one here, this is what we call the zero gradient. The reason why it's called zero is because our gradient works out to 0. Let's have a look at it. So let's just pick any 2 points again. So I'll just pick this one here, which is -4 is the x value. Okay, and our y values, say 7.3, something like that. Okay, and then I'll just pick another point. I'll pick this one here. So that's positive 3 and 7.3 again for our y value. Sorry, negative 7.3 for our y value. Okay, so let's plug those coordinates into our formula for the gradient. So m equals rise over run. So what is the rise? Well, there's no rise. Okay, the negative 7.3 here for our first coordinate and negative 7.3 for our second coordinate. So there's 0 rise. Okay, and our run. Well, there is a change in our x values. Okay, so we can see a change of 7 between, so the difference between negative 4 and 3 is 7. So you can put that there, 0 and 7. Now, any number, 0 divided by any number is 0. So 0 divided by 7 is 0, 0 divided by 2 is 0. So that's why we call this the 0 gradient. So let's have a look at our final one up here. So this one we call undefined, and another name for it is infinity. Okay, so let's have a look at this one. I'll do the formula over here. So m equals rise over run. So what's our rise? Okay, let's pick any 2 points first, any 2 coordinates. So I'll pick here. So I've got negative 4 is a y coordinate and negative 9 is our x coordinate. And I'll pick this one up here. So again, negative 9 is our x value. So there's no difference in the x values, but there's a difference in the y values. So we're going to do positive 5. Okay, so what's our difference in our rise? Well, the difference in the rise is negative 4, the difference between negative 4 and 5, which is 9. But what's our run? Okay, there is no run. So we have a 0 run because our x values don't change. There's no difference between negative 9 and negative 9. According to the rules of mathematics, when you divide any number by 0, the answer is undefined or infinity. So that's why we leave it as undefined or infinity. We don't actually give it a number. We just say it's undefined or infinity. So they're the 4 special types of gradients. Positive, when you're sloping upwards, and negative, sloping downwards. And then you have 0 is the horizontal line, and undefined or infinity is your vertical line. The final concept we want to have a look at is the y-intercept. Now the y-intercept is defined as where a line crosses the y-axis. Okay, so we've got 2 lines here, and let's have a look at those lines. And we're saying that the y-intercept is where the line crosses the y-axis. So these 2 cases are fairly simple. We just look at our y-axis and see where our y-axis intersects with our line. Okay, so our first line here, we see that y is equal to 3. So where does this line cross the y-axis? At 3. So we could say the y-intercept for this line is 0, 3. Okay, and in all cases, the x value is going to be 0. Okay, because you're looking at the y-axis where x is equal to 0. Let's have a look at this one. Okay, this was a positive gradient because it's slanting upwards or sloping upwards. This one is a negative axis because it's slanting downwards. And it's crossing the y-axis at, again, 0, negative 3. Okay, 0, negative 3. So we've looked at the y-intercept and the gradient. And the reason for that is because using the gradient and the y-intercept, we can develop any linear graph. The general rule for linear graphs is the formula y equals mx plus c. So y is our y value. M, of course, is our gradient, which we saw earlier. X is our x value, which we plug into our equation, and c is our y-intercept. So just make a note of that. C is our y-intercept. The other symbols you've seen earlier, you've seen the y's and the m, the y's and the x values. You've seen m, our gradient, and c is our y-intercept. We've seen a graph earlier, which was given by y equals 2x plus 1. Okay? So if we say that 2 here is our gradient and 1 is our y-intercept, let's try and graph it now. So m is 2 and our y-intercept c is 1. What we would do first is put a dot to mark our y-intercept. So remember that our y-intercept is 0 and whatever our y value is. In this case, it's 1. Okay, so we've marked 0, 1 on our graph. So what's our gradient? Well, our gradient is 2. So we know, and it's positive as well, so that we know that rise over run is equal to 2, which means our rise has to be twice the amount or twice the magnitude of our run. So we're going to, from our y-intercept, 0, 1, we're going to go up 2 units, so up to 3, but we're only going to go along 1 unit, okay? So our rise from 0, 1 up to this point, which is 1, 3, from 0, 1 to 1, 3, our rise is 2, but our run from 0 to 1 is just 1 unit, okay? So you can put those in if you like. So 3 take 1 and 1 take 0, which would also equal 2, okay? So just given these 2 points, we can now draw our line. Now my line's not going to be straight again. Do the best I can though. It is going to be a positive gradient, so it's going to increase. And yeah, we just got them. Just got the 2 dots. Okay, so that is our linear graph given by this formula here, which the general form is up here. So y equals m, our gradient, 2, and x is our values we substitute in, plus c, our y-intercept. So just going over it again, how I drew this graph. First, I plotted the y-intercept, which was 0, 1. Okay, that was the first thing I did. Then I looked at the gradient, which is 2, and I worked out then from 0, 1, I have to go up 2. That's our rise. And then the run had to be just 1, because 2 over 1 is 2. So then I plotted this point here.